to calculate the isotopes. So we're going to go over the equations that you have in your notes on page 39. The equations that you're going to need to help you today are that the mass number equals the number of protons plus the number of neutrons. You're also going to need that the atomic number is equal to the number of protons, which is equal to the number of electrons. And the other one we'll put up here in a little bit, but we're going to need to go over some things first before we do that. So just as a reminder from your notes the other day, you know that this is the mass number. So all the numbers after the elements are the mass number. So let's go ahead and start with hydrogen. When we go to hydrogen, and we go to our periodic table, we can see that hydrogen is H, which you should already know from your elements mastery tests. But then we need to look it up for the atomic number. The atomic number for hydrogen is 1. That will not change for isotopes. It'll be the same for every one. To figure out protons, now we don't have a charge, so we're good, so we need to look at other things instead. Protons then is equal to, up here, the atomic number. So in this case, it's 1. And then we don't have a charge, so our electrons stay the same. So electrons are also equal to here. And then I'm going to write except when there's a charge. So then this makes it 1. Now to find neutrons, you're going to need to take and use your equation mass number equals the number of protons plus the number of neutrons. So we rearrange that equation so that it's mass number, which is all the way over here. So it's mass number, which in this case is 1, minus the atomic number. So minus 1, that equals 0. Now to figure out the charge, charge is equal to protons plus electrons. And protons are plus, electrons are negative. So in this case, we have 1 positive plus 1 negative, which gives us an overall charge of 0. Okay. We're going to go through the same process with lithium and then again with beryllium. But I need you to realize we're going to come back and do hydrogen and helium here, but it's different because they have a charge. So let's go on to lithium again. Lithium is Li. Its number is on the periodic table, so lithium is 3. So I'm going to write 3 here. Remember, we have no charge, so it's equal to the protons, which is equal to 3. Still no charge, so the number of electrons is the same. To figure out our number of neutrons, it's going to be the 7 that's all the way over here. So 7 minus the atomic number, which equals, in this case, 4. So 4 is our answer. And then our charge, we have 3 positives plus 3 negatives. So our overall charge is neutral. Let's do one more so that you understand the repetition of everything. So we're going to do beryllium. Beryllium is Be. Okay. Atomic number is 4. So we'll put the 4 here. No charge, so they're equal to each other. So 4 and 4. And then I'm going to take 9 minus the 4, which in this case equals 5. Then to figure out the charge, I have 4 positives plus 4 negatives, which gives me an overall charge of 0. So you should be good on ones that don't have any exceptions to it, but let's do hydrogen 2 now. So we know from up here from the isotope above that hydrogen is H. Its atomic number is 1. Remember, that doesn't change. And then our protons should be equal to the atomic number, which is 1. But we have an issue. Our issue is that we have a charge. Now, in order to get a 1 positive, okay, that means we need to have more electrons or less electrons. So in this case, because that's the only thing we can lose, we can't lose protons, we can lose electrons. So in this case, in order to have an overall positive charge, that means we need to have one more proton than our electrons. So I'm going to show you the shortcut. So how many were we supposed to have? We're supposed to have 1. And I say do the opposite. So if we're adding 1, the charge, then we're going to subtract 1 electron. So in this case, we have 0 electrons on this hydrogen. Then our neutrons is going to be the mass number minus the atomic number. So 2 minus 1. So our number of neutrons is 1. Let's do that again, but we're going to do it with helium this time. So helium's symbol is He. So we come over to here. Helium is He, so it's atomic number 2. Still equal to the protons, so it's 2. But we have an overall charge. So we know we're supposed to have an overall charge of -2. So I'm supposed to have 2 electrons. But I need an overall charge of -2. So I'm going to take and do the opposite. So I'm going to add 2 here. And that means I need to have 4 electrons. So then I'm going to do my neutrons. 4 minus 2 equals 2. So that's my answer. Okay, let's do one where we know the number of electrons, but we don't know the overall charge. So lithium we already know is Li. It's atomic number 3. Our protons still should be equal, so it's 3. But we have 4 electrons, so let's do our math over here. So we have 3 protons plus 4 electrons. So our overall charge is -1. So let's do our neutrons then. 6 minus 3 equals 3. Okay. Be careful when you're doing other worksheets with this, because you need to double check what your headings are on all your columns or what it's asking you to find, because they may not be in this order. Remember, if you have any questions, please ask Mrs. Applegate or Mrs. Watt. We'll be glad to help you either before school, after school, PLT time, or even at later. Thanks. Have a great day.